Area word problems. So now that we're really working with polynomials, we can start to look at some more interesting word problems that have to do with area. And again, these reflect back on some things that you've worked with repeatedly. So we're just making it more complicated. So in this particular case, we're looking at a word problem dealing with a painting on a wall. I did not copy the whole word problem up here. I'm going to read it to you. You should have it in front of you as I read through it. The museum where Julia works plans to have a large wall mural replica of Vincent van Gogh's Starry Night painted in its lobby. Stop. So on the wall, they're going to paint a version of Starry Night. It's not the actual version. It's not on a canvas. They're going to paint it right on the wall. So here I've started to kind of draw what's happening. So here's my mural. They're going to paint that mural on the wall. That's my blue in the middle there. First, Julia wants to paint a large frame around where the mural will be. So I've given myself a large frame around the outside of my mural. So mural on the inside, frame on the outside. The mural's length will be 5 feet longer than its width. All right, so I've started to define some variables here. I don't know the width, so I'm calling W the width of the mural. So I've labeled the mural as W. And the length is 5 feet longer than the width. So I've called the length of my mural W plus 5. Okay, so I've defined my variables here. Please make sure you're defining your variables as you go. All right, so far I've got my mural. Next, the frame will be 2 feet wide on all sides. So for my frame here, I'm noticing that they're going to extend beyond the mural 2 feet in each direction. So 2, and then 2 feet, and then 2 feet, and then 2 feet outside of that. So each edge of the mural has another 2 feet outside of it of frame that's painted directly on the wall, and she's going to do that part first. Julie has only enough paint to cover 100 square feet of wall surface for the frame. How large can the mural be? So she has enough paint to fill in this space here, and she needs to have that be 100 square feet of wall surface. She can't have that be any larger than that. So she needs to figure out how big can they paint the mural so that when she extends 2 feet beyond that, she's got a 2 foot wide frame. All right, so I know I have my mural. I know I have my frame. Let's take a few pieces here. Write an expression for the area of the mural. So the mural, pretty straightforward. I've got a width and a length. Area of a rectangle is width times length. So my mural is going to be W times W plus 5. So far, so good? Okay. Write an expression for the area of the frame. So the area of the frame, I don't really have any dimensions of it, and we don't have a nice, neat formula for this kind of a shape. It's kind of an open box. It has a hole in the middle. However, notice it has a hole in the middle. That will come into play in a second. Now, what I can do is figure out the entire width and length of this whole project. So if I imagine that the painting is done, I have the frame around it, I have the painting inside, and I said, what's the area, what are the length and width of the whole entire thing? I can figure that out. So how I figure that out is I'm going to figure out the whole width. I know that the mural is W, and I know that above it I have 2 feet, and below it I have 2 feet. So it's W plus 2 plus 2, from top to bottom. 2, W, 2. So that ends up being W plus 4. So the whole width of the entire thing is W plus 4, 2 of each frame on either side. The length of the entire thing. I know I have W plus 5 here, but I have 2 feet on the left and 2 feet on the right. So that's going to be 2 plus W plus 5 plus 2, which is W plus 9. So now I figured out the area of the whole thing. And this is what we're looking at as part, part, whole. I have a part, which is my mural. I have a frame, which is another part. And I have the whole entire thing. And I know that the part plus the part equals the whole. But I also know, since what I'm missing is one of the parts, I can't add the 2 parts together to get the whole because I'm missing one of the parts. I can do the whole thing minus one of the parts. That will give me the other part. So I can do the whole area, and if I subtract the mural, that will tell me about the frame. So write an expression for the area of the frame. If I do the whole thing minus just the mural, that will give me the area of the frame. So I can do W plus 9 times W plus 4, the whole thing, whole length and whole width, and subtract the area of the mural, which we already said was W times W plus 5. All right, so this is my expression for the area of the frame. The whole thing minus the mural. If I take the mural out, that will just leave me this piece here. When we looked at those geometry problems where they say find the area of just that part. That's what we're doing here. Write and solve an equation to find how large the mural can be. So I know I have an expression for the area of the frame, but I also have an actual constant for the area of the frame. I know the area that the frame has to be 100. I have to stick it at 100. So if I do the whole thing minus the mural, that should be equal to the frame, which they've given us. They gave us the mural, they gave us something about the frame, and they did give us the actual area we need for the frame. So here we're just going to solve. So I use my distributive property. I come up with w squared plus 9w plus 4w plus 36. I distribute here. I have my negative w, so negative w squared minus 5w. That's still equal to 100. When I combine like terms, I end up with 8w plus 36 equals 100. Subtract the 36. I end up with 8w equals 64. Divided by 8, I end up with 8. So the width of the mural, it can be 8 feet wide, and it can be 13 feet long. So I've figured out the width and the length of this mural based on the other pieces that they gave me. So again, thinking as soon as we see this kind of a diagram, we want to start thinking about this as a part and the whole thing. And how can I use the fact that I know some of the parts and I can figure out some expressions for the whole thing to figure out other dimensions of parts of the picture.